Generally in DC-DC converters we use boost converter to increase the voltage, and we use buck converter to decrease the voltage, and there is other converter which can increase or decrease the voltage, that is buck boost converter, which can increase the voltage and which can decrease the voltage. So this converter can do about 2 converters works, and there is a drawback in this buck boost converter, that is it have high ripple current. That's why scientist Slobod and Chuk invented the Chuk converter. Actually it is written as a Cuk converter, but we can pronounce it as a Chuk converter, and it have low ripple and minimized EMI radiation and so many advantages. So finally this Chuk converter is similar to buck boost converter, which can increase the voltage and which can decrease the voltage, but it can eliminate the drawback of this buck boost converter, that is low ripple. Okay, and these both converters are inverting in polarity, means for example if you give 10 volts as input supply, you can able to get the higher or lower voltage, but that is in the negative polarity. That is the meaning of inverting topology. So same like buck boost converter, in Chuk converter also we will get the output as higher or lower to input, but that is in the negative polarity. If you give positive input, you will get the negative output. If you give the negative output, we will get the positive output. That is the inverting topology. Now we will design this Chuk converter in MATLAB. This is the circuit diagram of Chuk converter. Here we need to give the input voltage as Vs, and this converter contains 2 inductors L1 and L2, and it have 2 capacitors C1 and C2, and 1 switch and 1 diode is there, and we take the output resistance as R. Usually in DC-DC converters, inductor is used as a main energy storage element, but in Chuk converter the main energy component is capacitor. So if you give the input voltage as 10 volts, then you will get the output as higher than or lower than that, but with negative polarity. Okay, so if you want to test this circuit in MATLAB, we need to take some extra elements. Those are, if you want to measure the output voltage or output current, we need to take the voltage measurements, right? So that's why here I need to connect the voltage measurement at input and output to measure the input and output. Actually in our lab we will use the meter and voltmeters, right? Similarly here we need to use the voltage measurements and current measurements to measure the current and voltage. And then after that we need to give it to the scope. It can show the value as graphical format, nothing but the waveform format. That's why we need to connect the scope after voltage measurement. Okay, and here we are taking the switch, right? So it is bidirectional switch, like fully controlled switch. You can take any IGBT or MOSFET. So to turn on and to turn off the switch, we need to use the pulse width modulation, right? So that's why for this gate terminal we need to give the pulses. So take the pulse width modulation generator. So we need to give the duty ratio to this, then only it will operate. And we need to take the must needed one, that is nothing but the power GUI. GUI means graphical user interface. Without this we can't run the circuit. So these are the extra elements needed to design in MATLAB. And to design the Chuk converter, along with input voltage, we need to give the inductor and capacitor values to run the circuit. Now let's see the mathematical modeling of this Chuk converter for finding the inductor and capacitor values. First of all, I am taking the input voltage as 10 volts and I am assuming output voltage as minus 15 volts. So I need this as the output, and I am assuming ripple content as 1% and frequency as 50 kHz and load power as 40 watts. And we also need to assume the ripple voltage across capacitor 1, that is not more than 5%. That's why I am taking the 5% only. And we also need to assume the change in inductor currents, those are not more than 10%. That's why I am assuming as 10% and 10%. So first of all, find the duty cycle. To turn on our IGBT or MOSFET, we need to find this value. Okay, so duty cycle formula is minus V0 by V input minus V0. Then you will get the 15 by 10 plus 15. Then you will get the 0.6. This is the duty cycle value. So after that, find the inductor current values. So current across the inductor 1 is PS by Vs. we know that power is 40 watts, right? So 40 by input voltage 10 volts, then you will get the 4 amps. And to find the second inductor current, formula is PS by minus V0, then you will get the 40 by 15, that is equal to 2.66 amps. These are the inductor current values. So now find the inductor values. L1 is equal to Vs into D by F into change in inductor 1 current. So here we know that input voltage is 10 volts into D is 0.6, that divided by frequency is 50 kHz, right? Into, so here change in inductor 1 current, actually here the value of change in inductor 1 current is not more than actual current. Okay, here the actual current of inductor 1 is 4 amps, right? So 10% of 4 amps is 0.4. So change in IL1 is 0.4. Then you will get the 300 microhenry. Now find the second inductor value L2. That is equal to same like above, input voltage into duty cycle by frequency into, but here change in IL2. Okay, so you will get the 10 into 0.6 by 50 kHz into here 10% of inductor current L2 is 2.66, right? So 10% of this one means you will get the 0.26. Okay, so final inductor value is 384.6 microhenry. So now finally you will get the inductor 1 value and inductor 2 value. Now we need to find the capacitance and resistance values. So formula for capacitor 2 is 1 minus D by R into 8 into L2 into F square. So here we know that duty cycle is 0.6, R is nothing but ripple content, right? So what we taken here, ripple content is 1%, right? So 1% is nothing but 0.01, that into 8 and L2 we already find out here. L2 what you get, 384.6 microhenry. So here 384.6 into 10 to the power of minus 6, that into F means frequency 50 kHz whole square. Okay, then you will get the C2 value, that is 5.2 microfarad. This is the value of C2. Now let's find the resistance value. So resistance value is V0 square by P. So we know that V0 is nothing but 15 whole square by power we assume as 40. Okay, 40 watts. Then you will get the 5.625 ohms. This is the resistance value. Now find the capacitor C1, because we already find the C2 here. Okay, so now let's find out the capacitor C1 value. That is equal to V0 into D by resistance value R into frequency F into change in voltage of C1. Okay, we don't know this. Before finding C1, let's find the change in capacitor voltage C1. Okay, so that formula is Vs minus V0 into ripple content of C1. Then you will get the, we already assumed ripple content of C1 is not more than 5%. That's why I'm taking the 5% here. Okay, so just put here. So here Vs means input voltage. We know that that is 10 minus of minus 15. You will get the 15 into ripple content 5%, right? That is nothing but 0.05. Then you will get the 1.25. Now substitute this value here. You will get the C1. So we know V0 is 15 into duty cycle is 0.6, and we got the resistance value is 5.625 into frequency is 50 kHz into change in voltage of C1 is 1.25. We already got above. Now you will get the C1 value 25.6 microfarad. That's it. This is the C1 value. Now you will get the all values. That is C1 value and C2 value and resistor value, and here L2 and L1 also we find out, and duty cycle value is 0.6. Now finally we know the all values of this Chuk converter, like inductor 1, inductor 2 values and capacitor values and resistance values also. So now let's connect the circuit in MATLAB. Open your MATLAB. After opening the MATLAB, go to Simulink, click on blank model. Here we need to design our Chuk converter. So now take all elements as per the circuit diagram. So here we need DC voltage source, 2 inductors and 2 capacitors, 1 switch and 1 diode, and load resistance and voltage measurement, scopes and power GI, and also pulse width modulation and duty cycle. Okay, just take these all elements. First of all, I am taking the DC voltage source, and then I am taking the inductor, that is nothing but RLC branch, and I am taking diode, and I am taking one switch as MOSFET. You can take IGBT also, no problem. And I am taking voltage voltage measurement, and scope to see the waveforms, and pulse width modulation generator for DC-DC converter. That's why I'm taking the PWM generator for DC-DC, and I am taking one constant to give the duty cycle. Okay, and finally I'm taking the power GUI block. That's it. These are the blocks I need. Now just connect the as per our circuit diagram. First of all, we need to take the input voltage, then connect to the inductor 1. So I'm taking DC source and I'm connecting to the inductor. Then connect the switch and rotate the switch as per circuit. Then connect the capacitor and connect the diode. Take second inductor and second capacitor also. Finally connect to the load R. And to measure the voltage, connect the voltage measurement at the output parallel to the your load. Like we connect voltmeter in parallel to the load, right? So here we need to connect the voltage measurement parallel to the our load. So to measure the input, so take the same voltage measurement at the input side to measure the input voltage. Then connect to other scope, and finally give pulses to your switch, MOSFET switch. Okay, that's why I'm connecting pulse width modulation generator to gate signal and give the duty cycle. That's it. This is our circuit. If this names is confusing, just rename these names as whatever you want. I'm taking input voltage as Vs, right? That's why I'm taking the Vs. And this is inductor 1, that's why I name it as L1. And this is capacitor 1, right? That's why I name it as C1. This is inductor 2, so name it as L2. These are not necessary. If you want, just name it. And this is capacitor 3, right? This is second capacitor, right? So I'm naming this as C2. Finally name the R load as R. And here at the output we are getting the V0, right? That's why I'm naming it as V0. And here we measure the input as Vs, right? So Vs. That's it. Now give the values to input and inductors and capacitors as you calculated. So first of all, I'm taking input voltage as 10 volts, right? That's why I'm taking 10, and I'm taking the switching frequency as 50 kHz. Okay, now so go to pulse generator and take as 50 kHz, and we got the duty cycle as 0.6. So that's why take the 0.6, and we got the inductor L1 value is 300 microhenry. So take it as 300 E minus 6, and L2 value is 384.6 microhenry. So change the L2 value 384.6 microhenry. Click on OK, and we'll got the C1 as 25.6. So click on C1, change it as 21.6 microfarad, and we know that C2 is 5.2 microfarad. So change it as 5.2. Click on OK, and finally give the resistance value is 5.625. And actually, if you run the circuit, you can get the graphical view only, but to see as a numerical, we need to take the one display. So again, take the display here to see the output in numerical format, and give it to voltage measurement. To measure the input also take here. That's it. Okay, now we given all the values. Just run your circuit to see the output, and I'm changing the simulation time. Just run the circuit. It is running, it is compiling, now running, now it's ready. You can able to see here we are taking the input voltage as 10 volts, right? And we got the output as minus 14.6, means it is near to 15, right? So in theoretically I assuming it as a minus 15 volts, but in practically you will get the minus 14 volts only. Remaining is losses. Okay, and I already told you in buck boost converter or Chuk converter we will get the negative polarity at the output. That's why I'm getting the minus 14.06. Okay, but input polarity is positive only. That's it. Okay, we got the higher voltage than the input. If you want to get the lower voltages, just change the duty cycle. So now I'm taking duty cycle is 0.2 and click on OK. Now run your circuit. You can able to see here we are giving 10 volts as the input, then you will get the minus 2 volts as the output. Means it is doing the buck operation. That's why you are getting the lower voltage than the input value. If you increase the duty cycle to 0.8, then you will get the higher value. Here you can able to see we are getting the 29.53, so higher than the input value. It is operating in the boost mode. So that is the Chuk converter. It can decrease the voltage or it can increase the voltage.